Hello everyone. I am Dr. Srivatchan, Associate Professor of RMD Engineering College, Electrical and Electronics Engineering Department. We are discussing about microprocessor and microcontroller, and in this session we are going to discuss about timing diagram of 8085 processor, which is very important in order to understand how the processor process the information in terms of the calculation or the processing speed is concerned. Let's focus on it. As we know, microprocessor process the instruction and it takes some finite time to convert that operation into the required task. So all the instructions takes finite time, and what happens with respect to the finite time in terms of the processing is concerned, that will be understood with the help of timing diagram. So basically it's a graphical representation of how the processor process the information. So we'll be seeing in this particular lecture session. Now, let us move on to the basic understanding of timing diagram. Timing diagram is a graphical representation of the processor. It represents the execution time taken by each instruction in a graphical format. The execution time is represented in T state. For example, if there is a instruction like STA4200, this is an instruction, the command which is given to the processor to do a particular task. Here in this case, STA represents store accumulator in the given address of 4200. So what happens to the processor when it processes this instruction of STA4200? We can understand that in a graphical form. So that is the use of timing diagram. So timing diagram is a graphical representation of the processor, and it represents the execution time taken by each of the instruction in the graphical format. We will be able to see that in a graphical format. Now, what are the other key terms which are associated with respect to timing diagram is concerned? There is something called as instruction cycle. Time required to execute an instruction is called as instruction cycle. That is, how much time that is elapsed to execute an instruction is called as instruction cycle. Cycle is basically the thing which repeats in terms of clock is concerned. So the time taken to complete one instruction or execute one instruction is called as instruction cycle. Because processor takes some finite time to execute one instruction, based on that we will be able to calculate how much time the processor will need to take to execute a program. And we can understand in real time or in a graphical representation how it does. Similarly, for example, move A, B is one instruction and it's a 1 byte instruction. Now, what happens during this execution of this instruction? We will be able to plot that in graphical format and understand what processor is doing. Because that is one instruction. The time taken to execute one instruction is called as instruction cycle. There is something called as machine cycle. Machine cycle is the time required to access the memory or input-output device is called the machine cycle. So basically, all these commands or instruction, either they are stored in the memory or in the input-output device. The command has to come from the input-output device, or the command has to come or stored in the memory. So how much the time that is required, or how much time that processor takes to access that input-output device, or going to the memory and fetching it and coming back and does the required operation, is called as machine cycle. So these were the typical terms which we use in order to understand the timing diagram of 8085 processor. Machine cycle can also be termed as, machine cycle is a time required to complete one operation accessing the memory, IO, or acknowledging an external signal or request. So it could be an interrupt request, a subroutine request, how much time the processor takes in acknowledging that particular request. Okay, so it is a time required to complete one instruction. Instruction that is there, the command are stored there from the memory or from the IO device, where the signal or the external signal where there is a request. So that is the time period we call it as machine cycle. Usually machine cycle are expressed in terms of T states. Basically it takes around 3 to 6 T states to execute a mission cycle. Let us understand what is T state is. A T state is it is measured in terms of, that is, mission cycle and instruction cycle are measured in terms of multiple clock periods. How much clock period that it takes to access the memory or IO device or to execute an instruction, we express in terms of clock periods. So a portion of operation carried out in one system clock period is called as T state. So instruction cycle or mission cycle will be expressed in terms of T states. As I mentioned earlier, a typical mission cycle can take about 3 to 6 T states. So portion of operation carried out in one system clock period, we call it as clock period or T state. So you can see this is the clock period. There is a pulse, there is a positive edge, there is a negative edge or a falling edge, and there is a high, there is a low. So this is 0, this is 1, and there is a edge which is leading edge, rising edge or a positive edge, there is a trailing edge. So one set of positive and negative together is called as one T state. So, but usually it is measured in terms of from the trigger change. So it will be measured from this level to this level, that is called T state. Now let us understand the various operations, mission cycle operation that is performed with respect to 8085 processor. Mission cycle of 8085 has got 7 basic mission cycles. They are opcode fetch, memory read cycle, memory write cycle, IO read cycle, IO write cycle, INTR acknowledge, and bus idle cycle. And opcode fetch is basically a fetching the operation code from the memory, and it takes about 4 T states. So all the instruction of to the microprocessor, all the commands to the microprocessor will have default opcode fetch cycle, because you want to fetch the opcode from the memory or the command in order to understand what we wanted to do. Memory read cycle, memory write cycle, IO read cycle or IO write cycle, it depends upon the type of instruction which is being passed. So we will be seeing one by one. First, we try to understand the opcode fetch cycle. Opcode fetch cycle is nothing but each instruction of the microprocessor will have a command, and it's basically it tells the processor what to do, which is called as operation code, and it is a 1 byte opcode, say. And opcode fetches the instruction from memory and delivers it to the instruction register. And instruction register, during the first mission cycle, it fetches the opcode from the memory, and then it loads into the instruction register, and then it decodes and give it to the timing and control circuits. Now, this is a typical timing diagram of a opcode fetch. Opcode fetch contains usually 4 T states: T1, T2, T3, T4. And T1 state, basically what it does is it fetches the data or the opcode from the memory, loads onto the instruction register, and then decodes it. That is the basic operation of opcode fetch. So during the T1 state, the first clock period, the higher order address bus is available because it is an exclusive separate line, and there is a AD0 to AD7, which is the lower order address bus, which will be enabled using the address latch enable. As you can see, address latch enable is enabled during the first clock period. The address is available in the lower order address bus, that is AD0 to AD7, that is A0 to A7. So the address is available and address latch is high, hence it is loading the address. And since it is with respect to the memory, it is always available. So IO/M bar is memory. And since we are not reading from the memory yet, so it will be read bar. It will be a read bar. Okay. And so during the first clock period, the read bar signal is active high and it does not come into operation. So basically in T1 cycle, what we are trying to do is we are trying to load the memory where the opcode is located. And it is done with the help of address latch enable, which ensures that is a lower order address bus is available and the higher order address bus is loaded, and it points to the memory location and it is memory. So T1 state represents the loading the address and locating the memory location. And during the T2 state, what happens is the read bar signal will go low, which means active low, and address latch enable at the end of T1 state, it goes low and it is not available, which means that the address come data bus will become the data bus now. The higher order address bus is available. So you can see during the T2 clock period, this is basically what it does is, we can see this is act like a data bus. Now address latch enable is active low, and we can see memory is IO/M bar is 0, which means it points to the memory. Just hold on. Oh yeah. So it points to the memory. Hence, it will be IO/M bar is 0, which is active low, which means memory is located. So we have already located the memory because the address is located by during the first clock period. At the end of the first clock period, the address latch enable goes low, and what happens is the address come data bus becomes the data bus, and read bar goes low, which means a read operation. And we are reading that opcode from the memory, and it is loaded onto the data bus. So during the clock pulse period T2 and T3, the data is read from the memory, and which we can understand using the fetch signal. This is S0 is 1, S1 is 1. So 1 is opcode fetch, which means we are fetching the operation code from the memory, and we are trying to load it into the instruction register. So during this period, T1 and T2 and T3, the memory comes into play, and memory is available, that is M bar is active low, and status is opcode fetch, and we are trying to locate the opcode and loading into the data bus, and the operation code is loaded into the instruction register. And at the end of T3 period, the instruction register during the T4 cycle is converting that opcode and decodes it and gives to the control signal to do the required operation. That is why it is not coming to play. So basically T4 state is basically where the fetched opcode from the memory is decoded and machine cycle encoding and to create a required control signal. So this is a basic opcode fetch machine cycle of 8085 processor. Same way, we can also go through the memory read, memory write, IO read, and IO write operation. But all these memory read, memory write, IO read, IO write will take only 3 cycles, which is similar to that of this opcode fetch. Only difference is what we are using, what status signal we are using. That is the only difference. And whether it is a read operation or write operation, accordingly that signal will come into play. Now let us look into it. So memory read operation of 8085 processor, or memory read timing diagram of 8085 processor, as you can see, it is a 3 clock period which will take 3 T states. So T1, T2, T3, and higher order address bus is available. Lower order address bus is available during the address latch enable during the first clock period, and it's a memory read operation. So memory is available, M bar is 0, and initially it is locating the memory. So memory is not available initially. It's not a read operation. So we are just locating the memory during the T1 state. At the end of T1 state, the address latch enable goes low, and address come data bus becomes a data bus now. And after that time delay, M bar is memory is available, and it is a read operation. Read operation means S1 is 1, S0 is 0, 10 is a read operation, and the read is read. So the data is read, and it is loaded onto the data bus during the T1 and T2 state. This is a memory read operation. And the same thing, and during this, the memory is read, and this is how it is doing. And similarly for memory write operation, the same way, but only thing is it is going to have different status signal as well as the write signal. So it is also a 3 T states. So T1, T2, T3, there is a 3 clock periods. So during the first clock period, the higher order address bus is available. Lower order address bus is also available during the first clock period. The address latch enable is high. So because of which the address is located, since it's a memory operation, it is a memory, and write bar is not activated because it is not available, because the data bus is not available. During the T2 and T3, what happens is the memory is available already, that is 0, and status signal is 01. 01 means write operation, and the data is loaded onto the data bus, and this is available between the T2 and T3 state. So this is the basically what it does. It's loading of the data to the multiplex address come data bus between T2 to T3 state. Now, the same thing we can do it for IO read and IO write operation. This is also a 3 clock period. So let us look at the IO write cycle, IO write machine cycle. So there will be 3 T states, T1, T2 and T3. And lower order address is available when the address latch is enabled during the first year. Instead of memory, it is port address. Whenever we talk about input and output operation, we will always talk about ports. So port address is available and during the first clock period, and it is a write operation. So initially the write bar is active low, it is not available. Since it is not a memory, it is active high, that is IO/M bar. So IO/M bar is 1, means it is input output device. So hence it is available. At the end of first clock period, the address latch enable is low. Hence the address come data bus becomes a data bus. Then there is a port address. So between the T2 and T3 cycle, the write bar goes low, which is active low, and the data which is available is loaded onto the data bus. And because it is a write cycle, that is 0, 1 is a write cycle, 1, 0 is a read cycle. So this is a IO write operation because there is a IO operation. IO is 1 and write operation is coming into play because it is 0, 1 because of status signal. Similarly, IO read also be possible. It is also a 3 T states, and the clock period, first clock period, the higher order address bus is available, lower order port address is available. We will not say address, basically it is a port address. And we can see there is address latch enable, which enables the lower order, port address. And we will be locating the IO device with the help of IO/M bar is 1, and read bar is there. And read bar is which is not available during the first clock period. At the end of first clock period, the address latch enable goes low, and after some time delay, the read bar goes low, which means active low, and the status signal now is 1, 0, which is a read operation, and IO/M bar is 1, which is a memory operation. So memory read operation is done, and the data is loaded onto the data bus from the read bar operation. So these were the various timing diagrams of 8085 processor, basic mission cycles of timing, mission cycles of 8085 processor, and this can be done for various instructions as well. So basically we will have opcode fetch, memory read, memory write, IO read and IO write, which are all very, very basic operations which are performed with respect to mission cycle timing diagram of 8085 processor, which we have covered in this session. Hope the video is useful and interesting, and thanks for watching.